This is Mert. I first let me start by explaining how I got into performance optimization. I work at Google, specifically Google Cloud, and for about 4 years, we've been developing Angular. It started with AngularJS, but now we have mostly Angular code. We have a lot of developers, 300 or so front-end developers, and millions of lines of code. And somewhere along this migration, we noticed the Angular pages are not as fast as AngularJS pages, which was surprising because we're using these shiny things. We're using RxJS, Angular, all that. So how come it's slower? I had spent a couple of months investigating performance problems. Before we go into these learnings I gathered throughout this process, I want to categorize some components because not all the solutions, not all the anti-patterns that I discovered are applicable to all components. So most critical components are list-like components, which are table, tree, select. If you have lots of data going into these components, it's important that these components have good performance because that's where the data is, and that's where the problem is going to happen, and the browser is going to be slow because of the inefficiencies in these components. The second most important components are the components that go into list-like components. So if you have an icon that's in table, or a button, or a menu, it's important that these are efficient as possible. But if you have some components that are just has few instances on the page, it might be that you don't need any of these performance optimizations. So just keep in mind when I'm suggesting some patterns or anti-patterns, these are mostly applicable to list-like components or the ones that are used within those. So let's get right into it. First anti-pattern I'd like to talk about is usage of detect changes. Don't use this. Just use mark for check. There are valid cases you want to use detect changes in, like if you're using detach or reattach. But in our investigations of hundreds of components, it was mostly a code smell. Like we were able to convert all of those to mark for check calls. And the reason you don't want to use this is because detect changes is synchronous. If you do this in a UI thread, it will block execution until Angular executes change detection on the subtree, and so it will freeze your page. Mark for check, on the other hand, is asynchronous. You can batch it, you can call it 1,000 times, it won't do anything until the browser gets to the next tick. Also, mark for check doesn't violate the parent-child data flow, which Angular sort of assumes. Bonus point, use onPush. I saw in one talk yesterday, this was mentioned already. OnPush is good for less change detection cycles. Another anti-pattern I'd like to talk about is usage of built-in Angular directives when it's not necessary. So for example, in this example, in the code on the left side, you see ng class with a binding that's hard-coded. This is not as fast as just using the class attribute by itself because Angular has to initialize a directive and maintain that object in a runtime. Again, so this sort of optimization is not that important if you do on a component that has few usages. But if you do this on a component, a table cell, and then you have a table with thousands of rows and cells, this is going to add up. Why is ng class bad in this case? Let me back up a little bit and explain how ng class works. ng class, like ng style, ng4, and a lot of other built-in Angular directives, uses this helper class called Iterable differs. What Iterable differs does is that it tries really hard to compare two arrays and see what has changed. So if you have like a array, like two arrays like that before, it finds if something's been added, removed, or if it just changed index. It uses complex data structures to achieve this. But like in the previous example, you don't always need this. Another example of this is ng-style. And here we can just use a simple binding to achieve the same thing. And Angular won't need to use iterable differs. Again, if you have a table with like maybe 1,000 cells, that would mean 1,000 iterable differs. And those 1,000 iterables have maps, objects, all kinds of data structures to diff just this simple object, which it doesn't even need to. So just keep that in mind. Rather controversial example is maybe you don't even need to use ng4 because ng4 also uses iterable differs for good reason, because creating views are expensive, and when you create a new view, you kind of want to hold on to that, and if the array changes, you want to make sure you insert that view in the right place. But you might know how your array changes, items array changes better than ng4. And it might be possible to achieve better performance using just what ng4 uses, just without the iterable differs. And you can also even add caching. A lot of talks, a lot of examples I share is kind of like re-implementing the wheel. If you do want to re-implement the wheel, I'd say go for it. Just do it, because even if you fail, you learn some lessons that can be applicable elsewhere. But if you do want to come up with your own ng4, I'd say also add benchmarks just to make sure your work actually improves things. Turns out it's quite hard to beat ng4 efficiency, by the way. So another anti-pattern that we discovered is if you have a structure like this where ng template is within ng4, turns out Angular does something interesting. So for each item in this array, it creates a new ng template instance. So if you have 1,000 items, you have 1,000 ng template instances. But in in all cases, you can move ng template to outside of ng4, and that would mean one directive instead of however many items you have. So this is another anti-pattern that we discovered while investigating performance degradations in ng2 migration. Sorry, I called it ng2. Sometimes people get mad. It's Angular 8. So this is an interesting case because RxJS is really good in a lot of cases, but it's really easy to write code that's like, oh, subscribe to all observables and just update the view, right? Turns out if you subscribe to only what's visible in the page, you'll get a lot of good performance improvements. This is intuitive, but while you're writing the code, it's easy to miss this. And so we have our own table component. And when we did this change, we noticed 50% improvement in script time. And so how we track these changes is actually interesting. I kind of want to show you that too. We have this internal cool tool called PerfGate. What PerfGate does is it tracks the output of developer tools, like a script time, render time, and it records it. And we have CL, like a change list or a commit-based tracking on that. So if there's an improvement, we get a bug filed. If there's a regression, we get a bug filed. And when we made this change to only visible to only subscribe to things that are on the page, we saw significant increase in efficiency of rendering and significant decrease in memory usage. So I want to show you this, although it's an internal tool, I want to show you this because you might want to consider having a tool like this where it tracks your script time per CL basis, and you see this, it became, um, it was taking 5 seconds, and now it was taking 2.5 seconds. Those values don't matter as much as the percentages because we have like maybe a million rows in this benchmark. But even if you don't have resources to implement a tool like this tool is not, what it does is not rocket science. It just collects the data from output of the Chrome Developers Tool Performance tab. I think that was shown yesterday. Anyways, thought I want to show this to you. So yeah, the output, when I say this improved performance by this much percentage, I'm talking about the value we got from the tool. But I guess the tool has the advantage of running it in an environment, in a controlled environment. So if you have a developer's tool running, that might be susceptible to other changes, other processes that are running in your computer. So you might want to invest some into infrastructure for tracking performance degradations or improvements. Anyways, another anti-pattern that we discovered is DOM elements per cell, or DOM elements per component that is used within a list-like component. So in this example, if you have a table component, it's really tempting to write, oh, I'll just write a component that has a DOM level, that has a DOM element that is going to display an individual cell. This is good, but it adds DOM nesting. And DOM nesting means Chrome has to do extra stuff. When we tried this to remove DOM nesting, we got 15% decrease in render time. So another anti-pattern is using listeners per element. So if you have a tooltip, it's tempting to, in Angular, write like, oh, I want to listen to mouse over event over there. And you can add this per element. But if you have a lot of these tooltips on the page, like a tooltip per cell in a table, that could decrease performance as well. In fact, when we converted, so why does it decrease performance? Because it misses the fact that events bubble up, right? You can have one document level event listener that listens to mouse over event, and it will track mouse over events for everything on the page. And you can differentiate based on event.target. Unfortunately, this is how, current implementation of material tooltip, for example, uses listener per element. So when we switched from current implementation of material tooltip to our own implementation, we saw 9% drop in script time. Interesting note, the React does this on a framework level. So if you have only one event listener per event type, and everything else is propagated through synthetic events. So this might be a case where we learn from React. I don't know. Although I assume it would come with other problems when you have synthetic events. So another anti-pattern that we discovered, this is rather obvious, but we missed this for some reason. If you have layout thrashing within a component that is used within list-like components, so again, a cell in a table, that turns out it's really expensive because however items you have, that many layout thrashing happens. And when you see this, it usually looks like a large purple block on the performance tab. And the way you fix this kind of layout thrashing is just try to read at a higher level maybe, or don't read it at all. Or use a third-party library like FastDOM to read, write, but then batch those reads so you don't change anything in between. There's a full list of attributes that cause layout thrashing. Thought this might be useful to share. So for example, in our expanding row component, which is just a bunch of rows on a page, and then when you click on one of them, it expands, but collapses the previous ones. Turns out we had layout thrashing, and when we fixed that at render time, turns out that 80% of the render time was just Chrome trying to recalculate the layout. So that's how we got the improvement, by removing the layout thrashing in a child component. So another Angular, I guess, the anti-pattern is using components within list-like components that have lots of bindings and DOM. So material checkbox, for example, is a good candidate for this. It has dozens of bindings. It has a quite nested DOM. On the other hand, material soda checkbox has no template, very minimal bindings. Although when we we converted this to material soda checkbox, and we saw 8% drop in render time. But if you do this, you kind of lose some of the other things the match checkbox offers, like accessibility. So it's, but even if you add those accessibility improvements, turns out you still get pretty good improvement, actually 8%. So this is the case with a lot of performance optimizations where you kind of sacrifice readability or compactness so that you get more efficient component. In case you didn't know, some of the functions like set timeout, set interval, promise.resolve, these are all wrapped in Zone.js, and when these tasks are executed, Angular runs change detection. You might not want to run change detection. So for example, if you're just mutating DOM manually in this case, in that, that's what you're doing, try using run outside of Angular to avoid Angular change detection. Batching these microtasks turned out to be a great idea. We had seen almost 60% improvement in script time because we were doing set timeout within a child component of a list-like component. So if in a cell in a table, we were doing set timeout, which if you have a table with 1,000 cells, that means 1,000 set timeouts. That means thousands of change detection cycles. And we bash those by just doing it on a higher level. So that might be something else, something you might want to consider as well to improve performance of these components. For nice scrolling without any scroll jank, use passive event listeners. Passive event listeners are not natively supported in Angular. If you add like a mouse wheel, like in the left example, it will add an active event listener, which means Chrome is going to wait until that event list handler is finished before scrolling. And the reason for this is that Chrome doesn't know that it's going to, the event listener cancel the event or not. But if you add passive equals true, scrolling is just going to be faster. But you won't be able to cancel the scroll event, which in majority of cases you don't want to, or majority of cases I've seen, we don't cancel scroll event at all. So it's just a good improvement that you might consider doing using document.event listener. Will change. This is rather funny because when we need to use this, it's usually the case that we ruled out every other reason, and Chrome is doing extensive like re-rendering stuff. Will change helps when it hints to browser that something is going to change about that element, and so browser is able to defer some expensive calculations. Use this sparingly. Use this only when you need to. Only when you see that large purple block of rendering in Performance tab. But it's just one CSS change, it could dramatically improve performance of your app. This is rather intuitive. Use visibility hidden instead of opacity 0, because when you do opacity 0, Chrome still has to draw every pixel, and then it reduces the opacity to 0. But when you do visibility hidden, what Chrome does is it just tries to calculate the width and the height of the thing. So just inefficient to use opacity 0. This was another inefficient CSS. This was a surprise to us because we have like 50 or so front-end developers on our team, and none of us really knew why adding letter spacing would decrease performance. We just find out, thanks to that tool I was showing you, this tool is just tracking all the changes, and it was like, hey, there was an improvement when you removed letter spacing. And then we actively investigated that. I contacted the Chrome team, and they were like, oh yeah, that's just what happens. It turns out Chrome does some post-processing if you do use letter spacing with a non-zero value. So it first draws it, and then tries to insert letter spacing. And we got 15% improvement just by removing this. Also, so the reason we were doing this in the first place is because using letter spacing was also causing issues in some of our integration tests. Some of our Firefox tests were flaky, I think. So we removed letter spacing. We got an alert from PerfGate saying something improved, and then we investigated. Turns out it's something browser has to do extra. That was it. So let's talk more about it in the expert zone. The work that I presented is not just my work. I learned from a couple of really smart people, like my coworkers. Michael Liebman and the other Michael, who I just can't pronounce his last name. I'm sorry. I tried really hard, but oh, by the way, I signed up for Twitter for you because I thought maybe, I don't know. I saw every other talk signing up for Twitter, like showing their Twitter account. I was like, okay, I'll do the same. Anyways, thank you.